Good afternoon, class. Today we're going to be talking about rational equations and how to solve them. You've already done a little bit of simplifying with rational equations and expressions, really. But today we're going to be looking at if you have it equal to something, how can you solve for x? So we're going to start with this first example where we have 4x plus 3. 4 over x plus 3 plus 5 over 6 equals 23 over 18. And the trick with these is that we're always going to have an x in the denominator, right? And what we want to do is get rid of the x in the denominator and get it as a numerator somewhere so that we can actually isolate the x and figure out what it actually is equal to. And so the first thing we're going to do, though, is see if we have any like terms that we can move over and simplify before we start multiplying by any x's. And if we look, we actually see that we have 5 over 6 and 23 over 18 are both just numbers, right? So there's no x's associated with either of these. So we could actually start by subtracting 5 over 6 from both sides. And this will give us 4 over x plus 3 equals 23 over 18 minus 5 over 6. And so now, the denominators are not equal here. So before we can subtract the numerators, we have to make the denominators equal. So we have to ask ourselves, what can I multiply by 6 to make it equal to 18 so that I could subtract from this 23. And if we really think about 5, 6, that's equal to 15 over 18 if we multiply by 3 over 3. So and another way you could do this is just say, well, 18 divided by 6 is 3, so I need to multiply 6 times 3 to make 18, which means I need to multiply 5 by 3 to make 15. So this is really like saying 4 over x plus 3 is equal to 23 over 18 minus 15 over 18. And that is going to give us 8 over 18. So we get 4 over x plus 3 equals 8 over 18. And now these are both even numbers. So 8 is an even number and 18 is an even number. So we can divide this whole thing by 2 and get 4 over x plus 3 is equal to 4 over 9. And now we have two fractions on each, and one on one side and one on the other side of the equal sign. And when we have two fractions equal to each other, what we can do is cross multiply. And so by cross multiply, we're just going to say, we're going to start with this first one and say the denominator is going to be multiplied by the numerator of the other one. Same thing here, the denominator of the second one is multiplied by the numerator of the first one. That means 9 times 4 is 36. And that is equal to 4 times x plus 3. And this is just kind of a simplified way of saying, well, you could just multiply x plus 3 by both sides and then multiply 9 by both sides to get the divisor out from both. But it's just faster to say, to cross multiply and save yourself a step. So now we have 36 equals 4 times x plus 3, which means 36 is equal to 4x plus 12, which means we can subtract 12, right? And then get 24 is equal to 4x, which means that x is equal to 6. And that is your answer. So if you plugged in x up here, or x equals 6, you get 4 over 9 plus 5 over 6 equals 23 over 18. Another way that you could see this if you didn't want to go through the cross multiplication, which will always work for you to solve, but at this step, you could come over and say, well, I know I have something divided by another thing equals the same thing divided by 9. And so my numerators are equal, right? And if my numerators are equal, that means the denominators have to be equal, because this couldn't be like 10, right? Because 4/10 wouldn't equal 4/9, right? So this has to be equal to 9 if the things on top are the same. So another way you could have done it is said, well, I know from here that really x plus 3 has to be equal to 9, because 4 divided by x plus 3 is the same as 4 divided by 9. And then you could subtract 3 from both sides and get x equals 6. So that's another way that you could think about it, but this only works because the 4 is the same on top on both of these. This wouldn't work if you had like 5 or 6 or something here. It only works because you have the same thing and same thing divided by what you have as your x. Okay, so that one was kind of a start. This next one's a little bit more difficult, but not too bad. So here we have 1 over x plus 1 over 2x squared equals 1 over x squared. And again, for these where we have multiple x's in our as denominators, right? So in the last one we just had this x plus 3, but in this one we have an x here, we have an x squared, and we have an x squared. So we're going to want to kind of focus our efforts on eliminating the highest term polynomial, and if things are tied for the highest term degree polynomial, then we're going to look at the coefficient. So this one is 2x squared, right? And so we're going to try and eliminate 2x squared from everything so that we can have nothing left on the bottom here. And so the way we're going to do this is we're going to multiply everything by 2x squared so that this will end up canceling out. So we're going to multiply 2x squared by 1 over x plus 1 over 2x squared is equal to 1 over x squared times 2x squared. And so now I'm just going to distribute this 2x squared into each of these terms, and so I get 2x squared over x plus 2x squared over 2x squared, and that is equal to 2x squared over x squared. And now we're just going to simplify each of these expressions, right? So we have 2x squared divided by x. Well, your x's are just going to, your x on bottom is going to divide one of these x's in the x squared and just make this 2x, right? And then your 2x squared over 2x squared, you're just saying same thing over same thing. So something over itself is just 1 over 1, right? So this is just going to give us a plus 1 because these are going to cancel out and they don't go to 0. You divide the same thing by itself and you get 1 over 1 because it's a whole. And so that is all equal. So 2x plus 1 is equal to 2x squared over x squared. And here your x squareds are going to divide to give you 1. So you're just going to be left with 2. So now you have 2x plus 1 equals 2. We're going to subtract 1 from both sides. So we're left with 2x equals 1. Divide by 2. You're left with x equals 1/2. And that's your answer. Okay, moving on to number 3. We have 2 over x minus 1 over x squared plus 3x is equal to 1 over x plus 3. And so again, we're going to look at each of these and say, well, where's my highest degree polynomial on bottom? And it's going to be this one. And so once we've identified it, we know that we're going to be multiplying by this, everything by this, in order to eliminate this highest degree polynomial on bottom. But before we do that, we're going to ask ourselves if we can make it a little bit easier by factoring this term. And so we're going to say, is there anything that factors into x squared plus 3x? And in fact, you should notice that there's an x in both, so I can pull an x out, and it's really x times x plus 3. Right? If I have x times x is x squared, x times 3 is 3x. And so it's the same thing to multiply everything by x times x plus 3 as it is to multiply x squared plus 3x, because these are the same thing. So we're going to do that. So we're going to say x is x plus 3 multiplied by 2 over x minus 1 over x. And I'm going to leave this factored so that it's easier to eliminate later. And that is equal to 1 over x plus 3 times x plus 3. And again, we're allowed to multiply both sides by the same thing, because that's a special quality of equations, is that if we multiply one thing by on this side, we have to do the same thing to the other side. That's just basically one of the fundamental points of algebra. And so we're allowed to do that as long as we are multiplying the same thing on both sides. And we chose this because it'll end up eliminating this fraction on bottom here. And so we have 2 times x. When we distribute this into this expression, we have 2 times x plus 3 all over x minus x times x plus 3 all over x times x plus 3 is equal to x plus 3 all over x plus 3. So now we're going to go through again, just like each of the other ones, and simplify. So we're going to look here and say, well, we have 2 times x, but then we're also dividing by an x, so our x's are going to divide and make 1. And so we're just left with 2 times x plus 3. And then minus x over x plus 3 over x plus 3. So that just leaves us with a minus 1, because we have the same thing on top and bottom. And that is equal to x times x plus 3 over x plus 3. So our x plus 3's are going to divide to make 1. And so we're going to be left with x, right? And when I say divide to make 1, I'm really saying, well, this is the same as saying x over x plus 3 times x plus 3, right? And that is just saying 1 over 1. Now I have to distribute this 2 into this x plus 3, so I get 2x plus 6 minus 1 is equal to x. And then I get 2x plus 5. When I combine like terms, is 6 minus 1 is equal to 5. And this equals x. And then we want to isolate the x. So we want to move the 5 over by subtracting. I want to subtract 5. And we also want to move this x over so that we just have our x's on one side. So we're going to minus subtract x. We're going to be left with x is equal to negative 5. That is our answer. Boom. All right, we have one last problem, and it is a doozy. So we have this 3 divided by x plus 3 plus x plus 4 divided by x squared minus 2x minus 15 is equal to 1 over x minus 5. And so at first your eyes might get drawn to this x plus 4 on top, and you might be tempted to start doing some things with that, but you can't do anything until we've eliminated the highest term polynomial on bottom, which is this x squared minus 2x minus 15. And again, just like the last one, we're going to end up multiplying by something that is equivalent to this so that we can divide and it'll equal 1. But first, we're going to ask if we can make it easier on ourselves by factoring. So we're going to ask if there's anything that we know that multiplies to negative 15 but adds to negative 2. Let's think about it for a second. So you have 1 and 15. Those aren't going to add to make 2. But then you have 3 and 5, which could add to make 2. So I'm going to say x and x. And then since it's a negative 2, that means that our 5 needs to be the negative 1. And our 3 is a positive 1. And so negative 5 times positive 3 will be negative 15. Negative 5x plus 3x will give us negative 2x. So this is equivalent kind of to that. So we're going to end up multiplying everything by this, which will make this whole thing on bottom equal to 1. So that's just x minus 5 times x plus 3, all multiplied by 3, for x plus 3, plus x plus 4 over, and again, I'm going to leave it factored so that it's easier to see later when we are simplifying everything. Close the parenthesis, equal to 1 over x minus 5 times x minus 5, x plus 3. So now we're going to distribute this into each of these terms. So we're going to get 3 times x minus 5 times x plus 3 all over x plus 3 plus x plus 4 times x plus 3 times x minus 5 all over x minus 5 times x plus 3, and that's all equal to x minus 5 top over x plus 3, x minus all over x minus 5, and I'll zoom out a little bit. So again, we're going to go through and just simplify and see if we can make 1s anywhere. And so here, x plus 3 over x plus 3, that's going to make a 1. So we have 3 times x minus 5. And then plus this x plus 4, but then we have x minus 5, and x plus 3, x plus 3. So we just are left with the x plus 4, right? And that's all equal to x minus 5 times x minus 3. But again, we have this x minus 5 on bottom. So those can divide to make 1, and we're just left with x plus 3. So if we scroll down, we have to distribute this 3 into the x minus 5. So we get 3x minus 15, because 3 times x is 3x. 3 times negative 5 is 15. And then plus x plus 4, and then equals x plus 3. And then we're going to combine our like terms. So 3x plus x is 4x. Negative 15 plus 4 is negative 11. It's equal to x plus 3. And then just like in the last one, we want to isolate our x's and our constants. So we're going to add 11 and then subtract x. And that's going to leave us with 3x on one side is equal to 14. We're going to divide by 3. So we have x is equal to 14 all over 3. And that is your answer. And so these have been our notes on rational equations. Again, just as an overview, with each of these, we just started by basically asking ourselves, one, is there anything that we can combine, right? So in one, we could combine those fractions together and just get the 4 over x plus 3 on one side. But then we have to ask ourselves, how are we going to eliminate the highest degree polynomial, right? That's a denominator. And you're going to end up multiplying by that in order to get a 1 on the bottom. And in each of these, the second thing you ask is, can I factor that at all? And if you can, factor it, multiply by the factors, multiply everything, and then get to a point where you can simplify and combine like terms, and then you only have your x's left on top. All right, well, this has been our rational equations notes. Let us know if you have any questions. Have a great day.